I just said, the first task would be the first topic today would be the unit tests. We will create the unit test for the application we developed yesterday. And yeah, one more thing I haven't told you yesterday. You see that using the template types, we can actually we can say that we can overload the classes using different template types. So it means that if you have different template type, like different pattern of the template types, then you can actually define several classes with the same, using the same name. Yeah, so we can say that, not technically, but so from the naming perspective, we can say that we overload the classes here. So we create several classes with the same name. But on the other hand, as I said, technically each each class with the template type is unique. So yeah, we basically say that the class where the template type is integer is not the same comparing to the class which has the type string. Yeah, so basically for each type we can say that it is a different class. Yeah, and that's why, in addition, if we have multiple templates type defined, then that for sure will be a different class as well. Yeah, so this is for your information how it may work. Yeah, also just an interesting fact, you may face in future as well. Yeah. So yeah, okay, that was just for your information, and then let's try to create a unit test. So unit tests, we can create unit tests for any type, maybe not any type of applications, but definitely we can do it for the class libraries and for the console application. So basically the idea for us is that we run the program, not we run the program, but we call the methods, call the logic, and then we apply the checks. But first of all, let's so to create unit tests, we need to create a unit test project. Yeah, do it using ms test, and that would be test linked list. Yeah, so yesterday we developed our own linked lists, so here we can then test them. Test linked lists. Let's say my linked list, just because it's not about the generic linked list we created, but or not we created, but provided by C#. These aren't custom linked lists classes. So this one. Okay, let's go here. Let's go to yeah. So remember that we need to add that we need to create the project in the same solution. And so that's why I will basically use the same solution. I add the solution. Yeah, let it be demo, and then press create. So now we have the unit test solution here. And so it creates a unit test class by default. And the first thing I would like to do is that I remember that I need to add reference to project reference to the solution we want to test, and let it be. So that was the one we created yesterday. So that would be this one. Yeah. I don't need others. If you want, you can also add others, but I don't need them. And here we go. Yeah. So for save it. Yeah. See, remember if your file is marked with the star, it means it's not saved. Yeah. So just for you to, because sometimes students ask me why the program fails, but the code is correct, and sometimes the file is not saved. Yeah, I mean, I'm pretty sure that in almost all the cases you save your files, but just please don't forget, pay attention if your file is marked as, and if you do any changes, your file will be marked with the star. Just don't forget to save it. Even if you do some kind of you add a reference or something similar, you may see that file is not saved, and it's better to save it then. Okay, then you see when you add the unit, when you create the unit test class, unit test solution, you see that there's the unit test 1 class created by default. The name is not important. We can change it if we want. Yeah, if not, then we can keep it as is. It's so since again unit tests are created for the testing purpose, so it's mostly for the technical tests. That's why maybe the names are not really important, but sometimes it's sometimes it may be important. But I mean, if you do it for the testing purposes, then maybe the name is not the most important one. Okay, and yeah. So what we then start, we can again, as I said, we can take a look on the tests we had before. So let's say the activity 3 tests, and then I can take some logic from there. So I will use it as the reference for me. Then yeah, we can do it. Yeah. So you see there are some markers. So these markers actually help the unit test to be executed. So let's say, what do we have here? Here we primary test this class. So actually, we're not really interested in this my string. So in theory, let's say we want to test these cases. So basically, what the test means? The test means that we do we execute some code, we execute some actions, and we expect some results from this code. Yeah, if the code is executed. So that's why let's yeah, maybe. So yeah, again, we execute the code, we expect some results. Yeah, so this is what unit tests are about. Yeah, so we check if the result matches the expected result of some kind of action we do on some kind of logic developed. Yeah, so like here we have our own solution. So this is the class, so we can check if this class works as expected. Since this, yeah, and actually also from the testing perspective, I'm not sure if you are really familiar with the testing approaches in IT projects, in IT solutions. But how usually it happens, yeah, again, maybe a little bit about IT solutions. We as the programmers, we usually do is, it's not like we develop, usually and almost always, it's not like we develop something from zero. Again, it depends. You may face the projects where you start, let's say, everything from scratch, but that's, I think, at least from my experience, that's quite a rare case. Mostly you'll work with the projects that are started maybe a long time ago or some time ago, and they already have the existing solution developed. And the thing is that that for such cases, unit tests are needed to, yeah, first we check if, then we can compare. Actually, yeah, we can split, not split, but categorize the objects we want to test into 2 parts. So there can be the objects which work separately, independently, and I would say that my linked list, it is kind of independent class. So it means that this class is it works independently. So it simply we can say that, I guess you can agree that we can take this class, put it to other solution, then put it in another solution, and it will work the same in all the solutions, right? Since it is not integrated, like it's not connected, it's not linked with the other solutions. And so everything we have here, it is based on the, again, system class, system namespace, and also maybe some other generic namespaces, generic C# defined namespaces. But this class is developed independently from other solutions. Yeah, that's why the approach is to test this class, and on practice, such objects, such logic, such inclusions are much more easier to test than the logic which are linked to other solutions. So, for example, let's say that inside this class I would use another class I created. Let's say, for example, here I would use program class, or I mean some other class also defined by me. In such case, this would make, on practice, in such case, this would make the testing much more difficult, right? I mean, I guess you understand why, because in this case we have several custom solutions, and then of course we need to check the integration part. Yeah, so it's important because if our new class is linked to the existing class, then there may be some things which may break the functionality of the class with the objects created before. Yeah. So again, you may understand that if one object, an independent object, is tested, is created, then it is much more easier to test it comparing to the objects which are linked with each other. But I guess that's quite makes sense from real life as well. Yeah. And yeah, actually, also for the testing approaches, one thing I want to mention is that yeah, as I said, the integrations are tested. So it means that if you work with the large application, with yeah, where there are lots of different solutions inside, and you make the changes there, then there also may be different approaches used during the testing. So there can be the yeah, the integration test, just I forgot the term. Just forgot the term. The integration test and the regression testing. Yeah, so there can be regression testing, and yeah, basically then sometimes it can be there's the list of the solutions provided, not on the solutions, the list of the test scenarios provided, and then each scenario, like when we usually the changes are done in the cycles, at least from my experience, and I think it's done almost everywhere. The changes are usually done by cycles and deployed by cycles. So it means that there is the, let's say, sprint, let's say month or 2 months. Then there's the period when the changes are done. Developers do the changes, and at some point, all the changes go further. They go to production system, and then before they go to production system, all these changes are tested. And basically, the way of testing can be different. As I just said, there can be the regression testing where yeah, maybe not all the scenarios of the program are tested, but definitely the key scenarios are tested by the testers. Yeah, and if any defect reported, that means that something is wrong with our solution. But in this case, we have isolated solution, isolated class, so it would be much more easier for us. So, and let's take a look on what what is the functionality we can test. So let's start with the easy functionality. First of all, there is such a method we've seen in the, I think that was activity 5. Moment, let me check. I guess that was activity 5 with the card, yeah, with the card player. And there is, we can define an initialize method. Yeah. So it means that, again, remember, unit test classes are also the classes. So it means that all the parameters, all the functionality we have for the classes, it's also exists in the unit test classes. So it means that I can store the members, I can write the methods, and so on and so on. Yeah. So let's start with the collection. So let's say I want to create a collection. Yeah? So because the thing is that the tests are executed usually method by method, so I can store the values somewhere in between to not initialize the same thing several times. So let's start, and I would like to start with my linked list. Oh yeah, they have different names, but no, they have, oh yeah, they have different namespace. So let me use this namespace, and I think I can. I think I can use this namespace, right? Hold on. Think. No. It's oh, hold on. No, I cannot use this namespace. I just, one moment, I just added this solution. No, it's not visible. One moment, let's try again. And add project reference. Yeah, this is what I added. Okay, so let's try to rebuild it. And okay, it's rebuilding. Yeah, okay, so then let's try to add the namespace again. It's strange why I can't. This namespace. Ah, okay, I got it. One thing I forgot is that the class is not defined as public. And so this is also an important point. We need to use. Okay. So now, yeah, you see now we are using namespace and the class is visible. Yeah, so one more important thing to not forget is that the class, by default, the classes are defined as private. And so if you want to access it from another solution, we need to define public. We need to add public access modifier here. Yeah. So okay, and now we can. Yeah, actually we can create the method. Sorry, not the method, but the list. This way we can also use the constructor. Not actually, that won't be the constructor. That will be the initializer method. So what does it mean? It means that let's maybe try the following thing. I will mark it as just initialize. So this is the, and basically at every method we define here, it has specific parameters, specific purpose, and yeah, we then define such characteristics, such parameters, such identifiers inside square brackets. So yeah, then I can called method initialize, not called method, but I can write the method, and that would be initializer method. So let's say it is initializer, and this will be called at the beginning to initialize the, say, my unique list equals new my unique list string. Yeah. So again, initializer means this method will be called to initialize the main attributes we need for the testing. Yeah, so to prepare for the testing. So the method which is triggered at the beginning to prepare the parameters for the testing. This would mean that we need to initialize some values if needed. So yeah, in theory, in this case, we can simply do it this way, but just to make it more interesting for you, so you can see that we can have initializer methods. Maybe let's use this way this time. Okay, so yeah, this is for test initializer. And then we can write test methods. So basically the base of what we can do. And then test methods would be the actual test cases, test cases, maybe not really test scenarios, but yeah, or maybe test scenarios you want to test. So let's say we have test method, and the first one would be oh no, actually, yeah, so okay, we can initialize it here. Okay, maybe to make it more interesting, at the beginning I want to, or no, hold on. Okay, that would be fine. Yeah, and the first one, let's say and let's say that yeah, I have the test method, and the first test case would be that I can add the element. No, sorry, not the element. I can add the I can add the element to the collection. So let's test this. So in this case, what I do, I write that would be not test method. Say that would be add element. Elements here. So then this would be add elements, and here I can add elements to my list, right? So we want to be add last elements at the end. So that would be add last. I add the element hello, for example. That would be the first one. I add this my list. Add last. And it would be hello world. Something simple. So I add elements, and then I can write another test method. So this is the first test case. Yeah. So for each test method, we consider there's a separate test case, and then that would be methods test. That would be get the elements. Or maybe let's be get last, for example. Get last, I want to test this particular case. So what does it mean? It means that I need to get the last element and check if this is the same element I expect to be fetched, right? So in this case, what do I expect? I expect that the last one would be world. Yeah. So and yeah. So then I check, I assert equals. Yeah. And then basically for the check, like if you want to confirm that something, if you want to check the values, so we use assert. So let's then do it, and then that would be that you get from the my list my list, you get to get lost, yeah. So get lost, and you confirm that this would be the world. So what's the problem? Two. No, hold on. Two. So what did we have here? Get lost. And I have get by index. Okay, this is fine. Oh, okay, we have get lost. What was the problem here? Okay. Yeah, one more thing we also need to add is this thing. Yeah, I forgot to add the public. Yeah, like if you want to return some type, its type should also be publicly available. Yeah, so that means that for node we also need to define it as public. Yeah. And that would be fine. Yeah, because if I return the type, it means that this type should also be available for the class located outside. That's why it should also be public. Okay, this is the node, so I can comment. So it get lost. Why did I use comment? Why did I use lost? Okay, I think I can then get the value if needed. Why not? So for example, then for this one, okay, that's public. So I need to get current. Okay, so then that would be current, for example. Wait one moment. So what's the point? Yeah, okay, and then I get current. There's the issue. True. Oh, this is the method, sorry, yeah, it's not the getter. Okay. Yeah, so now it's better. Yeah, now it is better. Okay, so then we can check this. I think from here we can also, sure if we can call get lost. I think we can, right? And this may be a little bit confusing, but yeah, because these cases are, I would say, quite related with each other, right? Because otherwise, yeah, because otherwise I cannot really check if the elements are added. Yeah, so I need to get lost from here. So okay, let's try this particular unit test. So then to run the unit test, I need to run test. Let's see what we have. It's running, as I see. Well, hold on, or it's not built. No, I guess it should be built. Okay, it's successful. It's running. What's the issue? It's just running. Oh no, hold on, we have the error. Oh no, we don't have the error. Oh, okay, so it was just small. So we go to the errors, and what do we see here? One failed, get lost, and okay, we had the exception. Object reference not set an instance of okay, so here we discovered there is moment, let's check again. Yeah, but we discovered there is some issue, and let's check what is it. One moment, let's run again. Let's run again. Okay, so it says that there's no reference exception. Object reference not set to an instance of an object. So I can see the y. It is in the test get lost line 27. So I can go to the line and see that it is here. Okay, yeah. And here you can see that the test failed, and so this method it lost system no reference. Okay, so as an option, what we can do, we can debug it as well. So I can put the breakpoint here. I can put the breakpoint, and I can run the program. Debug test. So I can debug, run the debugger, and see where is the issue. The issue is. So let's see where is the no reference. Okay, I started and so that's okay. So let's check. Yeah, okay. So I see that the reference here is not null. The reference here should also not be null. Because this is namespace. Okay. So let's try to go deeper. Okay, so here I have current node get lost. And then no, hold on. Okay, so it tested differently. Yeah, I guess yesterday did we define get lost if we call it not from inside the class but from outside the class. Get lost. Okay, let's quickly define another method, public void, sorry, not void, but public t get lost element. And from here we simply return the lost element we have. But actually, I'm still not sure why the previous method failed. But again, let's try again. Let's run the debug again, and we can figure it out. So let's do it slowly, but okay, without building errors. Why it became inaccessible? What? Okay, it's crazy. Let's try again. Let's try again. Why it became inaccessible? Oh, it is accessible here. So just before I try it, let me rebuild it. Okay, so I tried to rebuild. Why this failed? BMO is an accessibility its protection level. My linked list string, my linked list. Did I change anything here? Oh, no, sorry, here's the problem. There's the typo. Sorry, my fault. Typo here. Now it should be fine. And so there may be some, yeah, so as you just seen, there may be some inconsistent, incorrect error messages because you have some errors in other places. So we're seeing just here. So yeah, need to fix. There may be some cases. So please be careful. Okay, let's run the unit test again. Let's run the test again and see what the issue is. The breakpoint is here. Okay, debugger is running, and I can see what's wrong here. But you see, so the unit test was useful already. We detected one issue. Okay, we have current element. Current element is next, and let's see what the current element is. Okay, the current element is not next element. Oh no, it has the current one. Okay. Okay, I step over here. Okay. And I get the current one. So, and okay, I don't have an exception here. Ah, hold on. Okay, now it's okay. Now it's this was executed. Okay, that was fine. Okay, we go next. Let's continue. And now we are back here. Okay, I got. No, I don't got it. One moment. My link list is initialized. Okay, and now we have. Okay, I got it. Yeah, basically, that's also the thing about the unit tests is that that they are actually created separately. So basically, it means that like if you want to initialize them and make them the same, so they will need to put the elements at the beginning. So yeah, because otherwise, one moment, we can test this one, and then this one will be executed. So here we would need to then oh no, hold on. Yeah, then we can do this the following thing. You see, here I have the test method. So let's say I define a private void get last elements. Not the void, but that would be the string. Get last element. And here I would return the last element from the list. Okay, this is done. And here I can assert if so that would look this way. Assert are equal, and here I check if this get lost element if it equals world. And then here I can check others. So maybe let me first remove the breakpoint from here, and here I can again get lost, so that would be element maybe 1, elements 2, and then here I can compare if it is elements 2. Okay. So then I can get the last element from here. It is get last element, and then I check if this is the element 2. Let's run the unit test. So you see it shows that we have two tests, and yeah, we see that two tests are now fine. And so we have the last elements. We checked that this is correct, and then we also checked if we can add the elements. So the Visual Studio 2 can open and close it. Okay, we will have maybe more examples. Right now, I would like to have 10 minutes break. Yeah, and then we will take a look on other examples here. So let's meet them at 25 minutes past 7. Let's move on 10 minutes. Okay, so I think we can continue. Yeah, so basically these are the tests we can basically the tests are executed separately. Yeah, so it means that this method is executed independently from this method, and this is important point because, as we just noticed, if we don't add the elements inside the method itself, then the previous ones what we added in the other test cases, they won't be counted. So it is important to add, or you can also add them on the initialization. Yeah. Again, two options: you add on the initialization, or you do it separately in each method. Okay, so here I can test get lost. What else I can test? I can test I can test the exceptions. So for example, I can define the exception that the element does not exist. For example, I can have the exception clause element not exist. So just simple exception, and then I can say that if no, then I throw new element does not exist. And by the way, it should also be public, since I want to use it outside the class. That's why I define it as public. And so this is then, yeah, I can test such case as well. So then if okay, yeah, so here we can have the case if next is, yeah, so here we can have the case when next is empty. So in this case I return default, or I can again throw the exception. Yeah. Element does not exist. So in this case I can also test that my test case it throws the exception. So how to do it? That is also quite simple, I would say. Yes, let's write it here. So that will be first, again, that will be test method. It still is test method since I want to test this scenario. That will be test method, and here that would be expected exception. And here I want to get the exception, and I say the type of the exception would be element does not exist, right? Yeah, element not exist. That would be the type. Yeah, of course that would be exception. Okay, it's better to add the exception at the end, but for this particular case, that would be fine. So yeah, and then we check public. Let's see. And then I say get not get, but get not existing index, and then I can try to get the element which does not exist. So in this case, let's say that I can add one particular element to the list. So let's say I add last. That would be, so let's say I add the element. Let's add some elements here. Yeah, and then let's say I want to get not existing index. So in this case, let's say I want to get sorry, get my list, of course, and then that would be get by index, right? Get element by index. So we have 4 elements. That means that the last index is 4. So let's say I want to get the 5th element. Oh, sorry, the last index is 3. Yeah, so it means that let's say I want to get the 4th element, and we expect the exception. So let's run the test and see the result. It's running. It's running. Yeah, so you see that now unit test is green. This particular case is green because it's thrown the exception I was looking for. Yeah. And one additional thing, what you can see here is the duration of the execution. So using the duration, you can also take a look on the performance issues. So it means that if the duration is, let's say, quite long, then you can say that there are the issues in the performance. Yeah, so you can also check the performance this way. And yeah, you can see the get last was quite fast because I simply have no loops. So for last elements, okay, for add last elements, that was okay, maybe that was just because I have this R equal. Yeah, it also uses the loop. If I compare the strings, I use it uses the loop since it needs to compare all the characters in the strings. Yeah. So that's why actually it takes the loop of 5 iterations. Okay. But yeah, so here the exception is expected and the exception is thrown. If, let's say, if I do something like this, then the exception should not be triggered and the unit test should fail. So let's run this test case again. And now it should fail. And you see that it is here. Test method did not throw exception we expected. Yeah, so here I provided the information that I expect the exception to be thrown here, and it was not there. Yeah, that's why unit test failed. Okay, so what else we can test? We can test loop, for example. So test method public void test loop, and let's say here I want to add the elements, and let's say that I need to find a way how I can test them. So let's say so to test the loop, it may be a little bit more tricky, but it's still possible. I need to, so how can I do it? For example, the easiest way maybe would be that if we find the array, maybe compare array, and then that would be new string, and then the element would be element 2, element 12, and basically copy paste these elements. So I just need to confirm that the loop will match these elements. Okay, and the last one. Okay, so this is done. And now we need to check the loop, and unfortunately I need to use the iterator because I need to access this array. So then I can do for each, and then I check this loop. So then that would be your element in my list. So this will be this my list. So here I can, here I can check. And then again, to compare the values, we can use assert. Yeah, we can use assert. And so to compare the values, I can check if the elements are the same, or I can also, as an alternative, I can use are equal. Yeah, maybe I'll write both options and then comment this one. So I check if the element equals compare array I plus plus. Yeah, plus plus is needed just to increment it on the further operation. Oh, and by the way, I can do that this way. So that would be one option. Another option that would be the similar one if I say is true. And here then I can compare element 1 equals. Okay, so I can use the method defined under the string, and this would be the same. Yeah? So basically, assertion helps us to check the condition. Yeah, so are equal, again it returns true or false. If false, then the assertion failed. If true, then assertion will pass, and then if all the assertions are passed, then the unit test is passed as well. So here I can compare two collections. Let's run the test. Let's run the test and see the results. Running. And you see that all the test cases passed here. And let's say that I have a mistake here. So in this case, if I expect something different to be added to the collection that I compare to, then this will trigger the test case failed situation. Yeah, so you see that it is failed now because assert is true failed. Yeah, so if I have such situation, it will fail. Okay, so this is this is about comparing. Actually, if you want, you can also write your own logic in the test loop method. Yeah, maybe it will not compare the values, but it can directly trigger the case that assertion will fail. So for example, I can write some test case which will always fail. So moment, test methods, public void. Let's say this should fail. It should always fail, and here then I can simply say assert, and then I write this fail. Yeah, so basically I can ask assertion to fail. Let's run unit test, and you see that this will automatically fail. yeah, so this should fail because assert failed. Yeah, so basically, if you, yeah, again, this may be not really relevant case, but the thing is that you can do some branches, for example. So let's say if, maybe just something really simple, yeah, if a equals 2, then fail, else if, example, else assert not fail, but hold on, if I a moment, if I guess, yeah, if we don't assert at all, then it should pass. Wait, let's check. Yeah, then it should, I think it should automatically pass then. No, I think, but I'm pretty sure it should pass. Yeah. So now see that it, like, if we don't have any assertion failed, then it will always pass. So assertion is needed to check the cases, and to check the cases which may trigger the situation which will fail the unit test. Yeah, so for example, when this is needed, I will maybe do it the following way and comment it out, so you just can take a look on it. For example, when this method may be needed, when this method assertion may be needed, for example, maybe in some test cases, we may have the situation test, let's say public void test, let's say 75% success. Okay, so for example, I want to test that, so here I entered 4 elements, and let's say that I expect that at least 3 of them would be correct. Yeah, so for example, then what I can do, I can do the following thing. So yeah, here I can then do the following thing. I can, yeah, so then here I expect no more than 1 case to be incorrect. So then I say integer number of incorrect cases, and I start with 0, and then I check if not equals, and like if not equals, then I increment number of incorrect cases. Yeah, but again, we'll need brackets since I have one statement only here. Okay, and then I check if number of incorrect cases is greater than 1, then I can say that assertion failed. Okay. So such cases where we can determine the result, yeah, not just by simply, as we did before, when we confirm that it is true, but we have some, let's say, more advanced logic to compare the values, to compare the cases. Okay, and I think these are the most interesting cases we just discussed. So my question is, do you have any questions?
Yes, hello.
Yeah,
I have two simple questions, I think.
yeah,
First of all, I wanted to understand. I think at the beginning of your code, when you are writing this array and in brackets you have a string. Yeah, that's the name. Why
yeah.
it is here and it is somehow related that the array was with string members, or maybe if there would be
I,
integers and in the, yeah.
yeah, I mean, this is for the test case. Um This is for the test case for the string. So it means that this particular test case would be done with the strings. I can create the same, or not the same, but a similar unit test class,
Mhm.
which will work with the integers. Yeah, or I can also, like in each method, I can define my own linked list. So that would be maybe this way. So here yeah, maybe let's write it then. Why not? So here I can say test methods. Maybe that will be long, but the thing is that I mean, for this particular class, I use only the strings. But if you want to expand uh, your your test cases, you can in each method you can declare your own array list and basically apply the checks on this array list. Or you can also create multiple classes, and then one class, let's say one class tests, it does the test on the tests on the string. Another class does the test on the integers. Another class does it on some kind of other type, and so on and so on. So you can create. So it's up to you to decide. You can simply make more cases. Yeah, the cases for separate cases for string, and then separate cases for integers or other types. Or you can also use several classes. Yeah, and then one class would be to test the strings, one class would be to test the integers, one class would test another type, and so on and so on. So this is the
Mhm.
point. And in
Thank
this particular case, I just simply declare I wanted to use initializer, so just you can understand that this is the method I can this code similar way as the constructor. Yeah. Yeah, and what's the second question?
Yeah, my second question is related with uh, do I understood correctly that basically the naming of the methods in test class
Yeah.
don't need to match the methods with how do you name it? It
Yeah.
doesn't matter basically. Yeah. No, of course for you to, or they should match.
I mean, no, I mean the method names would be the names you get in the test results. So basically, what you see here are the test methods. So the test method. So here is in the test case. They basically this would be the test case you have. Yeah, the test case add last elements. Yeah, so this is the name of the test method you see at the test result. Yeah, so add last element. This is the method you see at the test result. Yeah, so basically it says that here I executed test method at the last elements and it is passed, it returns successful result. Then again, it says I executed test method, which is named get last. It's green, so it means that no assertion failed there.
So they should be describing these namings, of
Yeah,
course.
yeah, 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 that's
Mm-hmm.
correct.
Not
That's
big
correct.
zebra, but what is happening there.
Yeah, 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 that's correct. Yeah,
Mm-hmm.
correct.
Thank you.
Yeah, using these methods, we actually see what's going on, and not what's going on, but what are the test cases looking for. But I mean, every time you can, I mean, you see you have the test detail summary, so you can navigate to the line, and then you'll basically be navigated to a moment to open and reopen, close and reopen. Yeah, so I navigated here, and then you can see what's the code there. So, but yeah, they should be understandable for you. Let's see the question from yeah.
Sorry, I just thought about third question. Is related with the name of the, no, not the name, the count of the methods. Do I need to create test method for each method I have in main class,
No,
in
no, no,
main?
no. I mean, this
No.
is no. This is up to
Okay.
you. This is up to you. What
Mm-hmm.
exactly you want to test. So basically, here
Okay,
you
thank you.
define each method for each particular test case. So again, here I want to test that, let's say, at 75%, or I mean, this is just a dummy method I created for my test case, but for my test scenario, but I mean, you may have such method. So basically, each test method is the scenario what you want to test, or the point you want to test. Yeah, so basically check if this thing works or this thing works for the class and so on and so on. Yeah, so you basically check if one particular thing works with your solution. Okay, and then the question from Wayne, how would you test methods similar to public void print? Yeah, basically the printing means this would be something what is seen on the screen. Yeah, so not on the screen, sorry, but on the console. Yeah, actually, this is a good point because I mean we can compare the strings. We can compare the strings you see on the console. So when you write the console, when you print, yeah, when you print, you actually print the string. So if you have the access to the string, we can compare the strings. But to compare the printing, this is actually a good question. I haven't seen this before. I think we could check. Yeah, I mean, you can compare the strings you print on the screen, but exactly if the print is correct, this is the good question. So, so output, yeah, because yeah, this is an interesting case. Let me quickly check. Okay. Yeah, I think this may be a little bit complicated, but maybe let me try. Yeah, basically this would be related with the input output we discussed.
But another question.
Okay.
Is it possible to be any errors in this case in printing?
In printing, I mean, we want
Printing
to
outside in console.
we want to validate. We want to validate if the output on console matches the output we expect.
Oh, okay.
So I mean, yeah, that was the question from Wiener. We want to match. We want to check if the console output matches. Yeah, actually, yeah, as expected, we can use the string writers and string readers. One moment. Yeah, maybe let's try. Let's see if this will be successful or not. So, but yeah, let's try. Why not? So where is my linked list? Yes, that was the wrong program. Sorry, this one. Yeah, my linked list. So yeah, let's try to create method print. So let's say the public void print. Let's say print elements, for example, and here I would like to print all the elements. So what I do for each, then I get the element in yeah, that would be that would be this, right? Yeah, and then let's say I print each element on a separate line, right? Line, and then that would be the elements. Okay, so let's try. I never tried it, but let's try. Why not? So first of all, again, I need to add the elements. Public void just print elements. So yeah, again, I need to start with the initializer. So let me do this right. And so yeah, I mean, every time we still need to compare the output. Yeah, the output will be the string, so we need to compare the output. So first of all, before we compare the output of print, we definitely need to check the string we are looking for. So in this case, I guess we can write it in loop, but again, I can also write it this way. So that would be string output expected. And here I can concatenate the strings. So that would be new line. So new line is this one. Yeah, so because again I expect every element to be printed in each line, so that's why I need to use this new line tag. Okay, hold on, this way. Oh no, hold on, I don't need to do something. It's something going to do this way. So then element 12, new line, elements blah blah blah, new line. Okay, so this is done. I don't need any error here. Okay, this is the output we expect. And then I need to check the printer. Yeah, then we need to use string writer then. String writer, and this comes from system input output. So I can write system input output, and I can use string writer, this one. So then I define string writer, and then I create a new string writer. So basically, what we will try to do is we will assign the object to the output from console. So basically, our object will read what is written on console. So let's try them this one. Yeah, system on string writer. Okay, this is done now. So then I set this outer. So this will be system console set out. Yeah, so this would be actually the So basically, in this case, we will print not on the console, but we'll print inside this string writer. Okay. Okay. This is done, and then I can execute this method. So that will be this my list. Print elements. Okay, and then I check if this one assert are equal, and then I check the output expected, and then I check the result, what is written in the string writer. So that will be just string, if I'm not mistaken. Wait, not too much. Yeah, go back. Okay. Okay, so let's see what happens now. Someone tried it, but let's see. Let's try the incapacity test. It's run. It's running. And seems not. Okay, so no, I guess I know the issue. So sorry, issue is not yet fixed. Yeah, so there's moment or not. One moment. Where's the issue? So did it actually printed the correct elements? One moment. So let's again check how did we create it. Oh, one moment. Let's move it on again. So I missed one thing. But a good question, Liana. Yeah, good question. Yeah, so we actually can see what is the result expected and what is the actual result. So yeah, the result expected is 2, elements 2, element 12, and then elements. I think I have the typo. Oh, no, that is correct. There's my yeah, so here there's one more line needed. And I think now it should work. Now it should, wait. Yeah, let's run test again. And because you see here it does not have one break at the end, but the actual result does have. So that's why. Okay, so still the error. Let's check why. So yeah, basically when you get such a assert error, it shows you where the issue is. And so let's see. So can you spot the difference between, so this is the expected result and this is the actual result. So where we have the differences. Elements 2, we got new 1, elements 2, 1, 2, 1. So do I have any typo? No, I don't have. I think there may be the problem with this new line. It's one moment, but yeah, the strings are the same, so there is no. I think. Oh, one moment. So we try it this way. Okay, this is what is expected. We have these steps here, and do we have them here? Oh, okay. So let's then try. Yeah, we have the tab here and the tab here. Do we have them here? Okay, yeah, we have them as well. I think this may be because of the new line. One moment. Maybe we can try the following thing. We can try, instead of using /n, let's try to use environments. So system environment new line. Okay. Let's try again. So I'm going to use this one. And then I want to use system environment UI again. It's done. Okay. And at the end as well. Yep, go back. This way. Okay, so 2, 1, 2, 1. 2, 1, 2, 2, 1, 2, 1, 3, 2, 3, 2. Okay. So let's try again. Let's try again. Yeah, actually, when you work with the new lines, this may usually trigger some issues. Or on practice, when you compare the strings, you may also have the tabs or something similar, and this is really not what you want. Oh, okay, fantastic. Now the test is passed. Yeah, so yeah, that was with the new one. Yeah, previously we also had sometimes the issues with comparing the strings using the new lines. Yeah, and sometimes it is better to use /n, sometimes it's better to use new lines, so it depends. But yeah, in this case, we'll need to use new line. So basically, again, what happens here, again, the same way I provide what is the result I expect. So I have the string what I expect to be written in the output in console. Then here I create the object string writer. So this will actually be the object where the console will write the content. Yeah, so actually the content will be written inside this string writer object. Yeah, so basically instead of the physical window we have, it will write the output here. And then I simply can read the output using this way, using this approach. And then I can compare the output as the string and the output I expect. So yeah, this is the way how we can test print. But yeah, this is a really good question. This is a really good question, and so yeah, this is a really good question. Quite interesting, yeah. So I guess I haven't tried it before, or maybe I did something similar, yeah. But yeah, exactly for the print, well, maybe not. But yeah, so it's really interesting thing what you can test. Yeah, and yeah, this is also for input output, since string writers basically, yeah, because when we provide the output in console, it also uses the writers, yes, and writer utilities, and this is how they can be used. Yeah, Elin says, so it's not so easy to write those tests. I mean, it depends on what are your goals, what you want to achieve using the unit tests. Like if you simply want to compare something similar, something simple, then just simply use test method, write your case, write some test scenarios, and compare. It actually, yeah, I mean, I agree that for long tests, I mean, on my practice, I'm not a tester. There are professional testers in IT sphere, so this is to separate, I would say, field in IT for the testers, yeah, quality assurers, the testers, yeah, these are the, I would say, separate. This is separate field in IT. Yeah, in IT projects, these are the people who apply the test scenarios. They check. No, they may write unit tests. I mean, for our particular case, it is for the training purposes. So I mean, we do everything here. But yeah, I mean, it depends on how complicated your test scenarios are. So if your test scenarios are not really complicated, then you may maybe not need to do some such advanced to write such advanced logic. Because yeah, for example, what are written in the tests we had in activity 5, for example. So okay, maybe not sure how complicated or how easy this looks like, but so all the time we compare the values. Yeah, we compare if player name is the one we expect, if the card count is the one we expect, maximum size is the size we expect, and so on. So basically, we compare some small things that can make our test scenarios. Yeah, so, but usually it is true, is false, equal. So we simply compare the values or compare the logical expressions if they are true or false. Okay, do you have any more questions about unit tests? yeah, I mean, these are just we got some we did some basics. Yeah, in practice there may be some more advanced features what can be applied, but for us this would be enough that we can create the test cases. Test scenarios. So, I mean, on practice, test scenarios can be let's say read from the file. So, yeah, so for example, we can add the CSV file, not add, but create the CSV file which has all the data. Then we read this data, we put this data in the program. Then the program creates in this case, that may create the list, add the elements to the list, and then do some actions with this list. So basically, on practice, we can also use the files. We can read the files, and we can create the test cases based on these based on these files, on the data in these files. So this is the point. Okay, if there are no questions, then we can go to the second part of today's session and it is, as I told you last time, we can talk about the mapping collections. So last time we talked about the list. So remember that the concept of the list is that we add the elements, and the elements are indexed. Yeah, so like 0, 1, 2, 3, 4. Yeah, so they are indexed using numbers. There's the sequence of the elements. We can then get the elements by index. We can basically store them sequentially. So there's the sequence of the elements, and then it's basically the sequence. Again, it's built in the way that we add the element. Then the element is by default it's added at the end. Again, we can also add it somewhere at the position we want. Yeah, so basically we have the control on the position. Yeah, we can decide where do we want to add the element. Yeah, we can add it at the beginning, in the middle, basically everywhere we want. This is up to us to decide. So this is first thing. Okay, then when we talk about the maps. So the maps is the key. I mean, the concept of maps is the key part, especially when we work with data. If we work with the data inside the program, like when we use the collections or arrays or something similar. And more important is when we work with the databases. Yeah, in the databases, and this is the key part for the tables, because all the tables in the database, they should have the keys and the values. And so each database table has the key, which means that, I mean, normally, I think there are the cases where database tables do not have the keys, but normally they do have the keys. And yeah, and then it simply means it builds the way how the data in the table is stored. So for example, yeah, first of all, at first, the keys must be unique in all the scenarios we have in programming. Yeah, if that's the database table or this is the map structure in the program code. In all these cases, we say that the keys are unique. Yeah, they should be unique. They cannot be duplicated. And basically, so this is the first point, they should be unique. And what does it mean? It means that if I have the key, I can let's say place my finger to one exact position in the table, in the map. Yeah, basically when I say the table, I mean the map or the database table. In this case, I talk about both scenarios. And yeah, so when I point to the key, I can see the mapping between the key and the value. And So when I point to the key, I can get the value. So and when the value is fetched, the values can be duplicated. So it's not mandatory that the values are the same, or if the values are unique. Values can also be duplicated. They can have duplicates. So, and how we can do it in the code. So first of all, for the code, we see that map structures, they have the keys and the values. And again, when we think about the code, we remember that so for the collections, we use the generic types. Yeah, and these types help us to define and identify the types of the items to be used inside the collections. So in this case, we have we can roughly say that we have two maybe not lists, but two sub collections. Yeah, we have one sub collection which is the key, and another sub collection which is the value. Yeah, and yeah, then we have these two, let's say, sub collections, and each of these let's say sub collections, it has the items. Yeah, we have, since it is sub collection, yeah, it has the items, and the item should have the type. So it means that I define the type for the keys, and I also define the types for the values. Yeah, the same as for the lists. The list has the type. The same as here, we have two, not really lists, but two collections, and they both have the value types for the items. And yeah, so for these cases, I have the collections which have actually double template types, and these template types are the keys and the values. So I have on the first position I have the key, the type of the key, and on the second position I have the type of the value to be placed, to be assigned to the key. So, and in this case, since I have both strings, then the first one would be the key, the second one would be the value, and they both are strings, so I assign the value for each key. Yeah, so I can add, and then then it means that inside the collection I have, like, let's say here I have 5 elements. So this will be one element, this will be another element, this will be another element. So in theory, we can consider this as the database table, which has the rows. Yeah, so that would be the first row, second row, third row, and so on. Yeah, so each of this pair we can that would be correct. Maybe not 100% correct, but technically that would be pretty much the same if we say that each pair is the row is built in the same way as the row is built in the database table. Yes, so one row, another row, another row. Yes, in this case, we can say we have the table with 5 rows. Yeah, the table has the keys and the values. Same as for the database table, because you can create, you can build the key using several fields. For example, let's say we have the database table, which stores the simple, that would be that we have the database table, which stores the persons. Yeah, so each person has the personal code, yeah, unique identifier, which should be the key, unique. And then we have the value, which should be, let's say, name and surname. So these two can actually be considered as the value. Yeah, so in fact, yeah, here we say we have only 2 fields. Now we have the key and the value. But in fact, I can make the structure more complicated. Remember that we have the structures. Yeah, maybe as an option we can try the same variant. Maybe let me create the demo solution for today. Demo solution for today. Main project. console application. It will be, and this is HTML 02/12/2021. Okay, I'll do it this way. So then that will be practical tasks. And I select it here, and I will add the solution. And create. So let's say I want to define the structure. So let's say I want to define the structure. The structure that would be, let's say, personal data. And then that would be string name. And clear string name would be just a getter and setter. And string last name as the surname. Also using the getter and the setter. Yes, so now I have two values, but it still is one date type, one structure. So yeah, let's then add the usage for the generics using system generics. No, system collections generics. Sorry, collections generic. This one. So, and let's create such improvisation for the person table. So what is the map used? Map structures here. So here is dictionary. Okay, so we can use dictionary. Why not? And then that would be dictionary. And then the key would be integer. Let's say that would be the personal code, and the value would be personal data. Be the same as persons. Then I create a dictionary. And here we go. Okay, so this is then done, and yeah, so now you can see that the keys are one integer value, but the values are defined as the structure. Oh yeah, by the way, string up. Okay, sorry, yeah, this one. This would be more correct. Yeah, actually, like in fact, there's no difference if you use string in uppercase and lowercase, but yeah, so you see such recommendation is the name can be simplified. This is just a recommendation that we use the, let's say, a simplified types for simplified names, type names for the generic, not generic, I mean for the simple sorry, not simple, but value types. Yep, so and here we can add the data. So for example, I said I add the person, and that would be, the key would be, let's say, code would be 1, simply 1, 1, and then the value would be okay, maybe that would be better. If I define personal data, that would be, let's say, person 1, for example. And then I assign the value for person 1. So what's the problem here? Oh yeah, let's say first one that would be check. So oh, okay, a moment. So this is one moment. Yeah, I can create the structure and what about the inline? Yeah, I can create the structure. I want to do it inline. One moment. Okay. Hold on. Personal data. Okay, yeah, the structure is created. Yeah, I mean, of course, I can create a new structure. Then that would be, yeah, of course, let's then define that's public. Okay, so we just talk just about that for a moment. Yeah. Okay, sorry, wrong screen. Yeah, I mean, okay, we need to initialize. But okay, that's fine. Okay, I initialize the structure and I add the data there. Okay, so yeah, then I add one person. So then I can add another person, secondary person 2. Oh yeah, name, surname, of course. Check. Surname, that would be Smith. Something. And for this one, that would be John. Surname. B. Okay, I want to be maybe Smith again. Alright. So yeah, and then I add, let's say, another element, and then we can use link and use the one the exception to print this print these elements. So moment, I think again, let's check if we can use all the expressions here. Yeah, okay, how it's printed them for a long time. Moment, all the expressions, and for each, so we don't have for each here. Yeah, 3. Try again. Okay, yeah. Need to then. One moment. Yeah, okay, then let's then use the loop. That would be easier and faster. So then I define var element in persons, and then I can print. Oh, for each, of course. For each, and then I can print element key as the value. Okay, so here we go, and here we can then check. Wait, run tests. No, we don't run tests. And that is the second one. See the results. Yeah, so you see that I of course need to print the key, so that would be, sorry, no, not the value, but okay, so let's then overwrite to string. And then from here, then I can return. Yeah, remember, using toString, we can provide the output we are looking for. So provide the output for string output for the element. So it would be the name, and that will be the surname here. Yeah, so now it is. Well, we have double checksmiths, I guess because here I added person 2 again, but yeah, so you just seen that we can have duplicated values. And duplicated values are allowed. But let's see what happens if we try to add a duplicated key. And so here I have some values, but yeah, let's say if I try to add duplicated key, what happens? Back. Yeah, so it will trigger the exception. Remember that for the lists, we also actually had the keys. And for the lists, we had the keys which are the nodes. Yeah, so basically for the lists, for linked lists, we also have the keys, and the keys are the nodes. Yeah, so in theory, we can consider the linked list as the map between the lists, or sorry, between the nodes and the values of the list, linked list, elements of the linked list. And so then in both cases we get the exceptions. If we try to add the same element to the list. So do we have any questions? The maps. Okay. Then we can move on. Yeah. Then there are also the sets. But yes, I think so. Just to not make you. Oh no, maybe let's finish with the sets, and then next time we will. Yeah, maybe let's go through the sets, and then give you the practical task. And yeah, next time we maybe will discuss more about the hashing values. So yeah, for the dictionaries we have the keys and the values. And then we have the situation when we have the sets. When we have the sets, and remember the I guess, oh yeah, last time I guess I shared the wrong picture. So let me open the relevant picture. Okay, let me add. Okay, let's try this one. Trend. Yeah, you can try this one. So you see that's the one I added to the chat that was cut. Let's let me remove it, change it. Okay, I can't it. Okay, so let me delete and then I'll add once again. So this one is better. Okay, this one's better. So yeah, so we can, maybe we'll later talk about the hash tables. Maybe today let's have a small example about with the list dictionary. So let's try list dictionary. Oh, hold on. No, okay, that's maybe won't be first example. No, let's maybe use sort list now. One moment, why don't we have? Okay, maybe let's sort the list now, and okay, it also has the key and the value. One moment. Okay, we have sorted set. Okay, this is what I wanted to. Yeah, let's try sorted set. This is what I wanted to try. So let's say we have sorted sets, and yeah, in this particular case, that's what this would be something similar to the list, but with some exceptions. So this is this may be a little bit tricky to understand what are the differences between the sets and the lists in for the collections. Yeah, so they all are collections, they are enumerable, they are the sets. Yeah, so we haven't discussed the sets yet, but they are quite popular for the collections. And let's have a look on one example. So I will take a look on the sorted set. Take a look on the sorted set, and yeah, so let's see what will happen here. So let me add some elements. And let's say I add the element to a, or maybe let it be a b, something like this. Then I add elements a, or no, maybe let's add it this way. Then I add the elements, say something like this. Maybe it's like this. And then let's maybe add one more element. This would be, so we have C, and here, let's maybe add some of this. So add these elements just to make sure that, so just to understand the sorting alphabetically. Yeah, so we will now talk about the sorted set. Sort means that the elements should be sorted. So using such letters, that would be easier for me for me and for you to see the how the elements are sorted. So we can loop through the elements in the same way, and I can write the element. Okay, so let's see the result. I have to run tests. Oh, come on. Okay, so let's see the result. Yeah, so you see that the elements are actually sorted. Okay, so this means that the sequence, how I add the elements, the sequence is not important. One more thing, I cannot add the duplicate elements here. So let's run the program. I mean, I can add, but the element will not be reflected here. So yeah, in this case, it will not trigger the exception, but the duplicated element will not be added. So yeah, basically let's have, I'll maybe go into the theory deeper on Monday, but today let's have a look on the quick let's have a quick look on the key features for the sets. And in this particular case, that we for the sorted set. Yeah, actually there are other sets as well. Yeah, there's the hash set as well. But yeah, what's interesting for the sort set? So first of all, this is sorted as it stands from the name, and it means that all the elements there are sorted. And so let's let me also show you one picture. Sort set C#. Let me also maybe, yeah. So if you open the, yeah. So basically, yeah, in all the programming languages where you have the sorted sort set. So in C# it's sort set. In Java it is called tree set based on the structure we have. And the idea for such sets is that, yeah, they are stored in the sorted way. So it means that all the elements there are sorted. And basically we can, yeah, in Java it is called tree set, and maybe I will show you tree set. And maybe I can show you the, yeah, so how such sets are implemented. So technically we have such binary trees, and the ideas of them is that that the elements, so again we have, let's say, the root element, and then if we, so this will be the first element, and let's say we add a new element. If the element is the same, we don't add it. If the element is greater than the root element, then this would be added to the right side. If the element is smaller, it will be added to the left side. Yeah, and so on and so on. So if the element is smaller, so let's say that, so the first element I add is 5, then the second element I add is 7. The third element I add is 7, it goes to the right side. The third element I add is 3, it goes to the left side. Then yeah. then the next element, let's say add, would be 4. So 4 is smaller than 5. Yes, it goes to the left. Is 4 smaller than 3? No, it goes to the right. Then, yeah, then let's say I add 1, it will go again to the left because it's smaller than 5. Is it smaller than 3? Yes, it goes to the left. Then next element I add, let's say 6. Is it greater than 5? Yes, it is. Is it greater than 7? No, it goes to the left. And so on and so on. Yeah, actually there is rebalancing. I will maybe go, maybe not. So let's see if we have the time. I will maybe explain this technically more on during the next sessions. But the thing is that the implementation is done in the way that the collection should always be sorted. Yeah, so I cannot add the element and make the collection not sorted. So, what may be the first point we need to think about when we talk about the sorted collections? So, what may be the first point we may think about? First of all, we need to have the elements which are sortable, right? Because, so let's say the example. Because when I say let me try to create the sorted set of personal data, and that will be as say sort set pers data. Let me try to create it this way. Okay, it works here, but what's the problem? Let's try to add the elements then. Let's try to add the elements. I'll maybe create uncomment this code. I will uncomment this code as well. Add person 1. Let me also add person 2. Let's run the program. Okay, we have error. Yeah, sorted person, of course. Okay, so the error is fixed. Let's run the program again. And I guess now we have the exception. We haven't had an exception. At least one object should be implemented. Yeah. So here we see the issue. Yeah, actually, I noticed one thing. Let's double check. If I had one element, then I think this may work. Okay, I realized it before. Yeah, this is interesting. This is interesting. If I add only one element, then I think yeah, actually this is quite smart. Right, yeah, this is quite smart. If I add one element to the sorted set, then it can be not sorted. Yeah, but if I add more than one element, then it will trigger the exception. So if I add more than one element to the sorted set, it will trigger the exception. If the elements do not implement comparable. And this makes sense. This makes sense because if I had the sorted set, so I must be able to compare these elements, right? Because otherwise, how can I sort them? Yeah, I cannot sort the elements if I cannot compare them. This makes sense, and this is the rule for the sorted for the sorted set. Yeah, and basically that's it. That's it. These are the main differences comparing to the lists. Yeah, so that they are sorted the way that they are sorted. Yeah, and they should be unique. And so these are the main differences comparing to the lists. We'll talk about these structures technically next week, so today is just the introduction. So do you have the questions from this introduction to the sets? Okay. Okay, so then it's fine. Then it's fine. We'll go deeper maybe on Monday. But today I want to give you one task. One task. So last time we implemented the linked list. Yes, I showed you how we can implement linked list by ourselves. I mean, so kind of our custom linked list. So what I want to maybe add, let me add, open one other project. So remember for the exercise 4 and 5. Maybe let's have a look on exercise 4. It doesn't matter. You can open exercise 3 or exercise 4. That's not really important. But what I want you to do. So based on what we, so this is an optional task, an optional practical task. You can work on. You can give it time. Now is for the array store. For the array store, we have one limitation. We have one limitation, which is abstract array store, which is the fact that we have the capacity. We have the capacity. We have the capacity for the array store. So I want you to try to think and also try to implement the way that the capacity is unlimited. So the same as for the linked list, we can add as many elements as we want. Yes, so in this particular case, I want you, maybe if you want, you can keep the default, you can keep the size. Yeah, but if you want, you can use the default size. And basically what the case would be, if you, actually my suggestion, try to implement this in the way that if I add the element which exceeds the capacity, then in such case I would need to create new array which basically it will create a new array as the object, which will then have the larger size. So it means that when I add the array, new element to the array, and the size now exceeds the size of the existing array, then it creates a new array with the exceeded size. Yeah, so yeah, this will be the task. Yeah, I will write it. So practical task for the array store abstract array store classes from the activity 4. So I just the logic so it can so we can now, yeah, so we can yeah, let's say add the element to it. Yeah, so I say to it the object collection. even if the capacity is exceeded. Yes, so basically it means that we need to adjust such insertion method. Okay, we have abstract. Let's go here. So we need to adjust this add method. Yes, so in this case, we need to adjust that the count exceeds the capacity. So in such case, you need to enhance the logic for the case when the count exceeds the capacity. Okay. So basically, again, in this case, we'll need to create new array. Yeah, I would say array which will have the exceeded size. And the size would be greater than the current capacity. There are several options. You can create the array which has the size, which has, let's say, capacity +1 in this case. As an alternative option, you can make it trickier and you can exceed the size by more than 1. I mean, you can create the array which has the size more than 1, but in both cases you need to copy the elements from the previous array to the new array. Okay, so no, this is the training task you can do. You can do now, or also maybe think about it during the weekend and then discuss it on Monday. So, is this task clear?
So we don't need to hand it in, yeah? It's the same as vector.
What you want to hand in?
No, we don't need to hand it in. It's just for us, yes?
I mean, you can hand it in, so we can discuss it next time. Yeah, so,
okay.
I mean, it's an optional. It's an optional task. You can, I mean, it won't be taken into account for your statistics, but so you can. It's a training task. So it's the training task. Okay, so is it clear? Okay, then I can give time to you. I will still be here. You can take the rest of the session today. In case you have questions, I'm still here. So I will be here. How are the things going? Any questions? Okay. So let's continue. Okay, so are there any questions? Okay, then I think we can close the session for today, and in case you have any questions, then you can work on it during the weekends. And on Monday we will take a look on the potential solutions. So let me push the code into the GitHub, and then we can finish the session today. So let me add the code and commit changes. So today is the 2nd of December. And let me push the changes. Results. Okay, so then thank you very much for your attention. Have a nice evening today. Have a nice Friday and have a nice weekend. And see you all on Monday then. Thank you and bye.
Thank you.
Yeah, thank you.
Bye.
Bye bye.
Thank you, till Monday.
Bye.